Today I'd like to have a chat about this capacitive touch switch circuit I've come up with. Basically it triggers a 555 timer in monostable configuration. What I'm looking to do, I'm looking to replace the 555 timer for a microcontroller, so we can have it in different modes. Like what I'm thinking is a toggle mode as well as a time mode, which we're doing at the moment with a 555 timer. I suppose you could do the toggle mode all analog, but I just like the thought of using like a PIC 12 or something. It's the same footprint, but it just gives you that more of the versatility to what you'd like the circuit to do. But the main part of the circuit that I'm more interested in is the analog side of it, which I'm using an LM358 Opamp. But so what I'll do, I'll get the schematic and we'll have a little walk through it. Maybe get the scope out and show you some waveforms from the Opamp that I had to clean up. Anyway, we'll grab the schematic. So here's the schematic of the breadboarded circuit I showed you earlier. Basically it consists of the LM358, well the one I'm using is equivalent of MOSFET and the 555 timer. The op-amp we got in non-inverting configuration with a gain of 37. I found if the gain was any more than that, I tried a gain at 50, it was the circuit, it was very unstable. I found that the gain of 37 works very well for this particular circuit. So basically the operation is obviously you touch this this capacitor here and it sends a little high pulse signal through there and it's gained through here, which in turn activates the gate of the MOSFET. Yes, it's very important to have high value resistor here, I found, because obviously we've got AC decoupled here, and any small amount of current's just going to float around at the input of this non-inverting input of the op-amp. So I think it works well with high value resistor there, just to take any tiny bits of current to ground. So you've got to remember with op-amps you've got a very high impedance input and apparently a low impedance output. So I think that's all I need to say about the capacitor. Yeah, I got a 0.1 UF ceramic there. For anyone who's interested, is the formula to get your gain for the op-amp. Basically got 1 plus R2 over R1, which would give us a gain of 37. So then we come back to the MOSFET. I did originally try an NPN transistor, but it didn't work basically because NPN transistors do require a current in the gate, and it was just drawing all the current from the capacitor, and it was just getting square waves coming through, which was sending the trigger of the 555 timer crazy. So with a MOSFET it works by a field, by a voltage, so basically we get no current from the gate to the source. So it gives us a nice clean pulse, which I'll show you on the oscilloscope later. So once the gate of the MOSFET's activated, we'll be taking the 10k pull-up basically to ground. So the trig pin will be going to ground, activating the 555 timer. Yeah, what else can I say about that? Yeah, here's the formula you'd use for the time output for the for the 555 timer. So it's R4 times C1 times 1.1. So you keep your capacitor the same value and just use a variable resistor. My particular circuit, it's 0 ohms to 2 mega ohms. So that basically gives me a timed output of, say, a couple of seconds to 30 minutes. So like I was saying earlier, the circuit I'm hoping to build is going to be using a microcontroller. That just gives a bit more versatility. You could basically use this on an I/O pin and basically write your code. If pin 1 is 0, do something. And you can also have another input, say like a switch on a pin, saying if high, go into trig mode, toggle mode I mean, or if low, go into time mode. So what I'm hoping to do is mount that on a PCB and have it running as a switch, on a switch plate. I'm not going to talk about the main side of it because it can be very dangerous. So yeah, what else can I say? I think I've covered most things on that, but I think what I want to do now is just show you on the scope this output if it's not filtered, and you'll see what I mean. Anyway, let's go to the scope. Yeah, so I've attached my scope to, let me get my pointing device. So what I've done, I've attached channel 1 to this point here with this 100 UF capacitor removed, and you'll see what I mean with the signal that I'm getting. So let's zoom in to the excuse my camera skills. Let's just zoom into the scope. So there you go. So I've got the scope set at 5 volts per division and I'm running off 12 volts. So this is my input without the capacitor. Look, basically we're getting I know that it has activated the circuit, but I don't like to look at it. If you measure the frequency of that, you're looking at 50 Hertz, and that's picking up mains through my body, which is not a very nice looking output at all. So what I'll do now, I'll connect the capacitor back into the circuit. Zoom in. This bird's nest that I've created here. So let's put this back in. That's connected back in now. So right, let's go back to the scope. Oh. So now I'll touch the input of the Opamp now, and you'll see you're getting a nice high pulse. There is still a bit of noise in it, but it gives me a nice clean pulse. If you wanted it really clean, you could put a higher value capacitor in there, but basically all I'm looking for on this circuit is just a cleanish high output to activate the gate to that MOSFET. So that's one thing to keep in mind when designing this circuit. I think the most fiddly part of it, to be honest, is the actual op-amp. They can be fiddly little swines if you don't know what you're doing. Well, I don't fully know what I'm doing. Most of the time it's all guesswork to me, and it just seems to work. But so there you have it. There's my capacitive touch switch. I'll probably put up some more videos on this, probably make it a series, showing you the actual PCB design. I don't know whether or not I'll document the actual power supply design, because really I don't want to be responsible for anyone's death if they are not treating mains with the respect it deserves. Yeah, there's lots and lots of safety features you need to think about when you're thinking of mains, especially with this, because basically you're touching a conductor here. You know, there'd be no use, you know, there's several different power supplies you could use. You could use the resistive power supply from the mains, obviously rectified out, filtered out for the DC through a Zener diode, or you could use capacitive. But the problem is though, there's no isolation there, so that'd definitely be a no-no, because we're actually touching it. It'd be a different story if it was an actual light fitting that doesn't have any human contact. But I'll probably go down the route of a little low powered switch mode, I think, from the main side, because the circuit as it is now only draws, I think, around, let's go to the my power supply. Yeah, it draws around 11 milliamps, and that's with the LED. In idle mode I think is around 9 milliamps, which is nothing really. You know, because what I'm looking to do, I'm looking for it to activate a relay, I suppose. It would be switching the mains conductor for the light, for a light. So it's getting late now, I'm ready for bed, so I think I'll leave it at that. I hope that this video is some use to someone. I'm sure it will be, and I'll probably catch you again shortly. Thank you.